Miss Brumwell. I'm going to be talking about section 3.2 in this video from Module 2. We are going to be looking at some theorems regarding our angle pairs that we learned about. So we have learned about 4 different kinds of angle pairs: corresponding angles, alternate interior angles, same side interior angles, alternate exterior angles. So what we're going to look at today is what happens when we have a transversal that is cutting through 2 lines that are parallel. And so here we have, if 2 parallel lines are cut by a transversal, so that's this picture right here. So P and Q are parallel. I know that because of those arrow symbols. And then T is a transversal. So remember, transversal is just a line that intersects 2 or more other lines. Okay, so T's are transversal, P and Q are parallel lines. So if we have this set up, so that's the if part, then what is true? So we actually have some special relationships that happen with these 4 angle pairs. Corresponding angles, we're going to abbreviate that. Corresponding angle, that's the angle symbol, postulate. Okay, so if you want to use the abbreviation, you are welcome to. Corresponding angles postulate. Okay. But what that says is that if we have this setup, corresponding angles are congruent. Okay. And so some examples of that, sorry, I'm going to actually move this up so I have room for this, are congruent. Okay, so corresponding angles, we should already be able to identify these, but like angle 1 and 3. So angle 1 would be congruent to angle 3 if we have this set up. 2 and 4. 5 and 7. And 6 and 8. Okay. We actually have the same relationships that happen for alternate interior, alternate exterior. Here's our abbreviation, AIA theorem. These ones are theorems because they're actually based off of this one. Alternate exterior angle theorem. And then same side interior angle theorem is SSIA theorem. So you guys are welcome to use those abbreviations in justifications for proofs, or if you're asked to give a reason for why you know something, you can use the abbreviations here as a justification. Okay, so if we have this setup, alternate interior angles are also congruent. Alternate interior angles are congruent. So examples of that, right, would be 2 and 7 or 3 and 6. So angle 2 is congruent to angle 7. Angle 3 is congruent to angle 6. Alternate exterior angles are also congruent if we have this setup. So in our picture, angle 1 is congruent to angle 8. And 5 is congruent to 4. All right. And last one, same side interior angles. So if I look at some same side interior, like 2 and 3 are same side interior, those are obviously not congruent, right? This one's acute, this one's obtuse. They cannot be equal. So these are the only ones that have a different relationship. Same side interior angles are supplementary. Okay, so instead of them being equal measurements, we're going to add them to equal 180. So the measure of angle 2 plus the measure of angle 3 equals 180. The other pair of same side interior are 6 and 7, so they have that same relationship, that the measure of angle 6 plus the measure of angle 7 equals 180. So all these relationships happen when we have parallel lines cut by a transversal. Okay, now we're going to do some examples with those relationships. Okay, so the first thing we want to get in the habit of doing, you guys, is identify what kind of angles they are. And so does that mean they're congruent or they're supplementary? So remember, those are our only 2 relationships we have right now. So right now they want us to find the value of x. So x is dealing with these 2 angles, right? We have an expression for each of those angles. Here's parallel lines. Here's a transversal. These are same side interior angles. So I first identify like what angles am I dealing with, and then the next thing is, are they congruent or do they add to 180? Same side interior angles add to 180. So I'm going to set up 13x plus 23x equals 180. So this is my equation. My justification, I'm going to put that here just to practice, you guys. My reason why these add to 180 is because of the same side interior angles theorem that says if we have parallel lines cut by a transversal, all same side interior angles add to 180. And then we can finish the problem, we can solve for x. So I'm going to combine like terms. So I've got 36x equals 180. Divide by 36. And we get x equals 5. All right, next one. Find the measure of angle NRS. NRS. So they want me to find this angle right here. So again, we have something involving x dealing with that angle. The other angle I have dealing with an x is this one. So what relationship do these two angles have? They're alternate interior. So because these lines are parallel, again, I know that from the arrows, two parallel lines cut by a transversal, alternate interior angles are always congruent. So the equation I can set up is setting these two angles equal to each other. And again, if I was asked for a justification, I would put the alternate interior angles theorem. They are congruent because they're alternate interior angles and we have the parallel lines set up. Okay? All right, I'm going to get all my x's together. I'm going to add 2x to both sides here. And now I'm going to get rid of that 32. So we got 8x equals 40. Divide by 8. And we get x equals 5 for this one as well. Now, notice this one didn't ask us to find x. They're asking for an angle measure. So we need to take this and substitute it back in. So NRS was this angle. So we're going to take 5 and put it in for x here. And that's the measure of angle NRS that I'm doing that for. Okay, 6 times 5 is 30, plus 32 is going to be 60, not 66, 62 degrees. All right, last one. Another one where we're just asked to solve for x. Again, I have parallel lines cut by a transversal. What kind of angles are these? Okay, well, these are corresponding angles, right? They're on the same side of the transversal and in like matching locations, top right, top right. Okay, so corresponding angles, when we have this setup, parallel lines cut by transversal are always congruent. So I'm going to set those two angles equal to each other. And again, if I was asked for a justification, I would use the corresponding angles postulate. Okay, this is a quadratic, right? So I want to set it equal to 0, and I do want the x squared term to always be positive. So I'm going to subtract the x from both sides and the 30 from both sides to get 0 over here. So I've got x squared minus x minus 30 equals 0. Okay, now we're going to factor. Remember, this is like a 1 sitting in front, so I want numbers that multiply to be negative 30 that would add to be negative 1. X's go here and here. Numbers that multiply to be negative 30 would be negative 6 and positive 5, right? If I add those together, I get negative 1. If I multiply those together, I get negative 30. Once I have it factored, I set each factor equal to 0. So there's one equation with that factor, second equation with that factor, get x by itself. So we get our two solutions, x equals 6 or x equals negative 5. All right, that is it for this video, guys. Thanks for watching.